Okay, good afternoon, all. Uh, I'm Mandar from Wockhardt Global School, MYP coordinator, physics facilitator, and even TOK examiner. So, the today's topic, what I have chosen is a scientist and imagination. Uh, as you are aware, being a physics facilitator, I am directly connected with the natural sciences. And I thought if I share some interesting information with the audience and uh, probably the students, uh, they will feel more interested to learn in sciences. So, for audience reference and for the discussion, I am sharing a small PPT which I have made for this webinar. So let me share the PPT with you all. Okay, now this is my brief introduction as I already mentioned here. And what led to this webinar is during my teaching, I have noticed that students who are initially curious or they are curious by nature, they want to know how things work actually, find science difficult or complex when they start getting solving problems, numericals mainly, or calculations or understanding complex theories. And what happens during this process, they start losing interest in science, and it's then it the subject merely remains for just passing out or scoring and not any more enjoyment in learning the science. So uh, I thought if I share some interesting things, few things with the audience or mainly with the students, that will provoke them to learn more into the science, at least knowing these stories. It will keep them curious to know more things, what is there. And probably that will let them to learn more in depth once the interest remains there. So this is what I thought for this webinar. Uh, if we look at even our own country, if you look at it, we have very few scientists who got the Nobel Prize, barring few like C.V. Raman, Hargobind Khurana, Bose. So even that was another aspect of choosing this topic, is why such a huge country, population wise huge country, not able to produce that many Nobel laureates over the years. So this was a burning question in my mind. That also led to take this topic for the webinar. So let's move to the purpose then. Yeah. So whole purpose of this webinar is to generate curiosity in learners' mind about natural science and inspire them to learn more about the science. So the focus of this webinar is not going in depth uh, about any theory or complex calculations or kind of numericals. No, it is just sharing few interesting things behind scientific discoveries and how scientists' imagination or intuition led to these discoveries. So this is the purpose of the webinar. So quick instructions. The duration of webinar is about 30 minutes. The nature of this webinar is sharing information and discussion. So initially you keep your microphone off when information is being shared. You can participate in a discussion by raising your hand and unmuting yourself for better coordination. And we'll have last 5 minutes for a few genuine questions. So you feel free to ask question, to share reflection, or put up your ideas. I hope this is clear to all of you. Okay. So basically, when we are talking about science and contribution of different scientists, so I thought I should share a few information regarding the contribution of ancient India and Greeks, because these two are very oldest civilization on this earth. So a quick information which you are seeing on the screen is, if you look at, it starts from 1500 BC, around 1500 BC. Shalva Sutra, which is a part of Vedas, okay, had mentioned about basics of measurement and just mention of Pythagoras theorem, but it was without proof. So there was a mention about Pythagoras equation or Pythagoras theorem and very basics about the measurements. So that evidence is there, but it was without proof. Then the next contribution or next mention about this was awareness of value of pi, which everyone knows now, 22/7, or the ratio of 22/7 or 3.14, and it's recurring a huge value. But that value of pi was not justified. Then also we had an idea of zero. That was the contribution given by India to the world. Everyone knows about that. Then coming back to fundamental science, Maharshi Kanad, maybe many of you know the name, visualized about the atom and its existence in every substance. So there are different atomic theories, like we know about Niels Bohr, we know about Dalton's atomic model, we know about Rutherford, but very ancient Maharshi Kanad also introduced about an atom and its existence in every substance. So that was another contribution. Then Varaha Mihir, he was a scientist come mathematician. He proposed that there is some attraction among the planets. I mean, he must have observed, or there is no evidence that any data he has recorded or so, but he proposed that there is some attraction among the planets. So probably by intuition or by imagination, he would have proposed that. So it was a prior step to establish gravity or gravitational force during the period. This period was 490 to 585. During that period, somewhere, he proposed that there is some attraction among the planets, a concept of force. But it was not mentioned about force. He was saying there is some attraction among the planets. Then who will forget Aryabhatta? So Aryabhatta thought of circular shape of Earth and its rotation around axis. So that was mentioned in India as well by Aryabhatta. There is evidence of this in his shloka in Aryabhatiya. He wrote kind of poem kind of things, a collection of poem kind of things, or shloka named as Aryabhatiya. There was a mention about shape of Earth and its rotation around axis. He even calculated the circumference of Earth around, say, 39736 kilometers. And when scientists calculated later on, it found to near about 39,843 kilometers. So he was very much near, considering that time no technology or no technical support or gadgets, sophisticated gadgets, equipments were available. Some written work based on his principle, Aryabhatta's principle, found by Mr. Ladd, who was Maharashtrian personality in 1864, which also contributed significantly in the field of astronomy and math. So his work then in 1875 was published in Holland by Dr. Kane. And then once it got published, the world came to know about it. So that was the contribution of Aryabhatta. Then many of us know about Bhaskaracharya, who contributed significantly in the field of astronomy and maths. So these are a few examples of contributions by Indians in science and mathematics. So if you look at it, in ancient time, India was very much contributing to the field of science. Now these people definitely took the help of imagination and intuition naturally, because that time there is no evidence that a sophisticated gadgets, equipments, or any technical help was available. Now, having that glorious past, if we consider a very large period after that, Indians did not pursue science seriously, it seems, in later centuries, except few exceptions like C.V. Raman, Bose, Ramanujan, Hargobind Khurana. These are the names who awarded Nobel Prize. So there is a huge gap from ancient India and later on in the field of contribution of science. So why was so? So that was the question which led me to go for this webinar. So if you consider now Greeks, another civilization on earth, contributed to the development of science and math. So many Greek personalities we are aware, because many students or many the early science textbooks mention about that. So Aristotle, who was a great philosopher, everyone knows, he contributed through his basic primary ideas about universe. Though many of his ideas were funny and later on proven wrong, but still it shows that his imagination and thinking in various fields. He thought of many fields, like he wrote around 150 theses or articles, out of which 30 articles are now available. And he wrote on philosophy, ethics, physics, botany, astrology, biology, and politics. So see the fields he contributed. This itself shows that Aristotle, how imaginary he was. Then we all know about Pythagoras, Anaxagoras, Democritus, Thales. These are few names who contributed in the development of sciences when society was bounded by religious beliefs. So after them, it comes the name of Copernicus, Tycho, and Kepler, who contributed in physics and astronomy. Hello, welcome audience, those who are present. Are you getting what I'm sharing? Hello?
Yes, sir. Yes,
Yeah,
sir. This is Anjali here.
Yeah, so are you getting what I'm sharing?
Sir, actually, I just joined.
You just joined. Oh, no problem, no problem. But you are seeing the PPT, right, which I am shared.
Yes, sir.
Okay,
I'm seeing.
Yeah. So those who have joined little late, quickly I will give the brief. Like we were discussing the contribution of ancient Indians and Greeks in the field of sciences. So the PPT which you are watching have mentioned about few personalities, those contributed in very past in ancient India, and similarly the Greeks. Okay, so this is what the brief introduction, those who have missed out first few minutes. The what led to share this with you is because many students and many common people, they find science not interesting because they feel it is based on only calculations, complex theories, and solving numericals. So the purpose of having this webinar is to share few interesting stories of scientists and how imagination helped them to discover the things. I hope you are getting now idea, right? So I'm moving to next slide. So based on the works of Tycho, Copernicus, and Kepler, Galileo started working in physics and astronomy with set of experiments. Okay, now here is one interesting story about Galileo. In 1583, when he was 17 years old and attending a lecture in a church, he saw one lantern which was oscillating. So a brainwave struck immediately in his mind that if this lantern is oscillating, can we have a similar kind of oscillation setup? And with this idea, he experimented with the use of pendulum. Okay, he proved that time taken by pendulum for one oscillation is depend upon the length of a thread, but it is independent of the mass of the pendulum. So for this experiment, at that time, when no accurate digital stopwatch or any clock or whatsoever available, so what he did, he used his pulse rate or heart rate to calculate the time taken by the oscillation. Are you getting? So he also proved that time taken by two objects of different mass to fall on the ground is same if air resistance is not there. So what he did in Italy, Tower of Pisa. I hope you know the Tower of Pisa. Yes or no? Hello? Am I audible?
Yes, sir, you are audible.
So are you aware of Tower of Pisa in Italy?
No, sir.
Okay, so the Pisa is a famous tower in Italy where he conducted Galileo an experiment. So he took two cannonballs of different weight, okay, and he threw those balls on the ground, and they could reach on the same time. So with this experiment, he concluded that even time taken by two objects of different mass or weight to fall on the ground is same if air resistance is not there. So right now, a small student also knows this, but in 1583, when there was science was not progressed, there was no technology available, he could imagine this kind of thing and could experiment. So that was the greatness of Galileo. So one more interesting story about him was he was present for opposing geocentric model. That means Copernicus first introduced the concept of geocentric. That means that time people were believing that Earth is at the center and other planets, including Sun, revolves around it. Now, right now, we find this very funny because we know everything now. But imagine at that time when people were unaware about these facts. That time, Copernicus and later Galileo proposed the theory that Earth is not at the center, but Sun is at the center, which proved true. Okay, so this theory is called heliocentric model. That means Sun is at the center and other planets are revolving around it. Okay, but when he proposed this, he was prisoned by that time by the church because they felt that he is talking against the God. See what was the condition of science that time. So they prisoned him. Okay, they sued him about this kind of proposed theory. And you will find very surprisingly, see the line, in 1992, I mean 350 years after his death, Pope John Paul II, he officially accepted that church was wrong and Galileo was right at that time. See, 350 years. So how he was ahead of time. These are interesting stories. Okay, then what was another thing is Galileo died in 1642, and at the same time another famous scientist, everyone knows name, Newton, was born. So no need to give his introduction. So he changed the scientific world by his path-breaking contribution in the field of mathematics, light, mechanics, astronomy. His invention of calculus, okay, still it is debated, like Newton invented calculus first, or another name of scientist was Leibniz. So who invented? But some evidence shows that Newton first invented the calculus, but he kept it is unpublished. He kept it secret for some years. So then his contribution to the physics is phenomenal, like gravitational force as a fundamental force of nature, the nature of light are classic examples of highest degree of imagination. See the power of imagination. That time, again I'm repeating, no technical help, no gadgets available, no sophisticated instrument, but still these scientists could come up with the theories which are still valid after their death 400-500 years, right? So one more interesting thing about him is, you can see here, when he became a professor at the age of 26 in Britain, okay, his first lecture was attended by only 3 students. Can you imagine? That time only 3 students attended his lecture. No one was present in his second lecture, but still he continued to give lecture to empty hall or empty classroom for 17 years. It is written in the book. See, these are interesting things about this scientist. Then another name is James Clerk Maxwell, who is well known for his electromagnetic theory. Okay, so he established relationship between electricity and magnetism through his equations, which later on actually practically conducted by Oersted experiment, then Michael Faraday. But the base was given by Maxwell. Now, this is another example of imagination. So how could he get these equations? So probably he could have thought, he could have imagined, and he proposed the electromagnetic theory. Then he studied in depth the Faraday's work before publishing his work on electromagnetism. The most funny thing about him was he had an habit of working on weird theories. I mean, you will find it's very funny. Like one example of this was sleeping habits. As per this theory, he used to sleep evening from 5 to 9:30, then followed by reading or study from 10 to 2. Then after this, he used to exercise from 2 to 2:30 a.m. by climbing up and down the staircase where he was living, and then again sleep from 2:30 a.m. to 7 a.m. So still you will find it's a very weird kind of thing, but he was experimenting this sleeping theory, sleeping habits. Okay, so finally what happened, he would have continued, but finally what happened, his neighbors complained about this as they were getting disturbed by his the climbing of staircases, and finally he had to stop. So see, from Galileo, from Newton, and now Maxwell, you will find these all scientists, apart from out of box thinking, they had some funny elements which may be part of their imagination, who knows. Okay, then we'll move forward. Yeah. So finally, everyone knows a celebrated scientist. Who can forget the name of Einstein? Okay. So another giant in this list is Einstein. After Newton, whose work in physics is considered as a total paradigm shift. When it gave a total different dimension to the science, is Einstein. He became celebrity scientist. I mean, people used to keep his photos in their houses and rooms. Once he got famous because of its Nobel Prize and theory of relativity. So he questioned Newtonian mechanics and special theory of relativity. So in 1905, he published 6 theses. And out of these 6, 3 theses, those totally changed the world of physics. I mean, they were photoelectric effect, Brownian motion, and special theory of relativity. So itself, one thesis itself is a big achievement in many of us in our whole life. But see the imagination of Einstein. He could produce 6 theses, and most surprising fact that he wrote this thesis on relativity in 5-6 weeks during break time when he was working in patent office in Switzerland. See, most astonishing fact that for writing these 6 theses, he did not use any lab for experimentation. Like, it was purely imagination, intuition, and thought-based thesis. Okay, he used to say that I always carry my lab in my pocket. So it means he used to propose theory using the calculation by his pen. So that was meant what he was saying about his carrying the lab in pocket. Okay, so there are many more scientists like Planck, Heisenberg, Pauli, Schrodinger, who contributed in the development of science with their discoveries, with a lot of interesting stories. But due to time constraint, we have to stop here. But before ending this webinar, okay, let us hear the quote from Einstein on imagination. He quoted that imagination is more important than knowledge. See, this is what a great scientist like Einstein has quoted. Knowledge is limited, but imagination encircles the world. So if you see all these contributions by the scientist, you will find it was purely role of imaginations, then intuition, and of course experimentation. But the backbone of setting up the theories was imagination and intuition. So this is what we have to end here. So I've referred for this book in Marathi actually. It is known as Kimayagar, which is published in 2014 for these stories and facts about scientists. So any questions or reflections? Okay, we'll stop here. Thank you for attending the webinar. Bye. Bye.